Hello and welcome everyone. Very happy that we are all together again. In the previous tutorial we ended with selecting the HVAC machine that will feed the zones we have from the mechanical equipment tab here. But indeed those types that we have selected from are not all the types that we can use from, as we have some other devices that we can use. So to access more extra types of the HVAC devices, we can go to the system tab and then to the mechanical equipment, and after that we press on load family. So we need now to load some families or a family that we can use as an HVAC device. And for that we will go to the Revit 2017 and then go to the libraries and then the US metric. This is because we are working according to the British units. And after that we select a file that is called the mechanical, as the mechanical file includes the mechanical equipments, and then MEP, which stands for mechanical electrical plumbing. And after that, as we are working now on the air side, as the ducts has the air flowing through it, so we need now an air side component, and for that we'll select that air side components. And as you see, we have here different types represented in different files. Here the air conditioners, the air handling units, the air terminals, the coils, the energy recovery, the fans and the blowers, and so on. Also we have the terminal units, and this is our target now, as we need a unit that supplies us with the air we need. So we will select the terminal units, and here we have many templates or many families. Those for the fan coil units, for example, the ceiling ducted, it's hanging on the ceiling and there are some ducts that going out of it to feed the zone, and the horizontal pill drive and the direct expansion one. And also many types. When we going down here we will find that we have many versions according to the different mechanical structure and the different technologies. But when going down, we will find also we have the variable air volume boxes, not only the fan coil units. So this is a variable air volume box for the outlet plenum, which means that it's hanging on the suspended ceiling or on the plenum. And this is the L structure, and this is the T structure, this is the transition, this is the Y structure, and the bypass one, and the dual duct one. So all of those are some different mechanical structures. And for example, we can use this variable air volume unit with bypass, and then we press on open, so we will select that type to work on it. And now after capturing the family we need now to select it, so we will go to that tab here and select the family that we have just loaded. So the family that we have just loaded is this one, variable air volume with bypass unit. We select it, and here we can insert it. So when I insert it here, for example, we'll find that we have the same warning that we faced before. The variable air volume box doesn't appear. This is because the offset level is 0, so we need to make it at an offset level that enables it to be in the range of that ceiling or in the margin of that plenum. And for that we will make it, for example, to P 3200 millimeter. And now when inserting it, we will find that exactly it appears. So I'll insert it here and then press escape, and that's it. Here we can express it in the 3D form when accessing it, and then press on that selection box. And now let's zoom in a little bit. So that's the variable air volume box we have. It has an output. This is its output, and it has a rectangle cross-sectional area, and this is its input, and it has a circular cross-sectional area, which means that this side will be hanged with a circular shaped duct and this side will be hanged with a rectangular shaped duct. So it receives the air from its input, then it controls the amount that will follow out of it, as it has some dampers. This is because it's a variable air volume box, so the dampers control the amount of air following through it, and then it goes forward through the output to feed the branched ducts and to feed the zone we have. Very good. Now let's close that tab, and then this is the variable air volume box we have in the 2D form, and our aim now is to connect it or to make it to feed our zones that we have with the air terminals. So if you remember, we have made the air terminals design on the previous tutorial for that room and that one and that one and that one. So I can paste the air terminals again at that ceiling. So I have copied them and I can paste them here. Here those are the air terminals we have, and our target now now is to make the variable air volume to feed those air terminals or to feed those zones. But as we learned before, each zone is fed separately by a separate device, which means that we have those two spaces which represents one zone. So those two spaces will be fed by that device or that variable air volume, and those two spaces here will be fed by another variable air volume. This is because those two spaces we consider them before to be a zone, and those two spaces we consider them to be a different zone. And now the first thing we need to do is to specify the position of the variable air volume. So we can select it here and we can move it up here to make at that position, for example. And as you see, as we mentioned before, this is its output and this is its input. So we need its output to be in front of the air terminals we have. This is because the output will have a duct and this duct will be connected to those air terminals. And to do so, we easily select it and then we rotate it. So to rotate it, we easily press on that rotate command here. And then it asks us to specify the first line of the angle. So we specify that line and then specify the second line of the angle. So we need it to be rotated with an angle of minus 90 degrees. This is to make its output here in front of the west direction. So to do so, we will rotate it with an angle of 90 degrees, but clockwise, not anti-clockwise. So we select that line here. And that's it. And now we can make it to be down a little bit by pressing on shift and the down arrow. Very good. Now what we need to do is to go with a duct out of this variable air volume, and to make a duct or to connect its output with a duct, we easily press on that box here. So when pressing on that box, you can see we have a duct that is extended with us to that direction. So we can make it to be until this point here. This is because we need to feed those two air terminals from that main duct. And then we press on escape, and after that we will make another duct, and that duct will start from that point and it will end at that point. And after that we will make another duct. So we go to the system again and then duct, and that duct will start from that point and it will end at that point. But you can notice here there is an error, as we cannot connect this branched duct with this air terminal. So we can expand that error and see it, and here it tells us that the vertical height between the branched duct and the air terminal is not sufficient to connect between the branched duct and the air terminal. And this is because if we need to connect the branched duct to the air terminal, we use an LPO, so that LPO must have a specific radius, as we learned before. But when the vertical distance is small, the LPO cannot be installed, as the LPO need a larger vertical distance to be curved, or to take its curved shape, or to take its sufficient curved shape. And to understand what's happening well, we can see it from the elevation side of view. So we go down and select that east direction, for example. And here, as you see, this is the air terminal that we are working on, and this is the branched duct, and this is the main duct here. So that's the main duct, that's the branched duct that we need to connect to our air terminal. So you can see the air terminal is very close to the branched duct, and for that we need to increase the distance between the air terminal and the duct. And to do so, we can cancel that error, and then we can select that air terminal. So that's the air terminal that we have, and go to its properties. So you can find that its offset distance is 2800. So it's a larger offset distance, which make the distance between the duct and the air terminal is very small. And for that we will decrease it to be, for example, 2600, and you see it has gone down. So when going back to the plan view, here we go up and select the ceiling, and after that we can repeat what we have done again. So we go to the system and insert a duct, and from that point to that point here, and that's it. Congratulations, we have managed exactly to connect the duct or our main duct with the branched duct. And now let's see that again in the elevation side of view. So when going down again to the elevation, we will find that we have a sufficient distance now to make the LPO, as we said, or for its LPO to take its required curved shape or its required radius. So the LPO is connected to the air terminals with no problems. But what I need you to know is that until now all what we have made is only for the illustration purpose, as we are not making a precise design at all. So we are supposing now some examples only for the designing idea to reach you. But after finishing all the designing steps, we will jump to the complete projects, at which we will make some accurate designs with some very precise dimensions and well-organized plans for all of the project steps. For example, we will make the ducts and the air terminals require dimensioning calculations, but for now we just inserting some random ducts to see how can we make it. Alright, now let's go back. Here what we did on that air terminal will be done on all the air terminals we have, so we can select all the air terminals here, that one, and that one, and that one, and that one, and now we will make this offset distance to be 2600 instead of 2800. Here let's change it to be 2600. Now we will connect that air terminal with that duct, and for that we will press on duct again, and don't save, we don't need to save now, and start from that point to that point, and that's it. But you know, we don't need that extended part of that duct, as the duct will be ended at that position. So there is no forward air terminals, or there is no forward rooms or zones for that main duct to feed. So we don't need that forward extension, and for that we will extend the command that we have learned before, which is the trim extend. So we will go to the modify tab and then choose that option, which is trim extend to corner. So we will make an elbow shape between that duct and that duct. So we will select that trim extend command, and then we will select that first duct and this second duct to be the second one, and that's it. Here we have managed to make it a beauty design with a curved elbow here, so we don't need any extensions or any parts that are not important for us. So that elbow shape is more efficient, as it produces the less disturbance and the less losses, as we said before, in the air during its flow through it. So that's about the first dune that we have, and we have connected it with its variable air box. Now for the second zone, here this is the second zone that consists of this room and this room. So we can copy that variable air volume box. Here we select it and then press and copy. And now start from that point and insert it at that point, for example. And then we need to rotate it. This is because its output is in front of the west direction, but the air terminals here are at the east direction. So after selecting it, we will rotate it. Here to rotate it, we can choose that rotate command, but we have a very simple way for doing so, which is to press easily on the space on your keyboard. So when I press on a space, it's rotating easily as we need. That's what we need. Its output is in front of our zone. And then we will make another duct by the same way, by pressing on that box. So the duct is moving with us. We can end at that point and then press escape. And then what we will do easily is to connect that main duct with a branched duct to that air terminal. So we go to the system tab and then duct again and start from that point and end at that point. And that's it. Here we will do another one from that point here to that point, and then a third one, so this duct will continue to feed that air terminal, and for that we will start from that point here to that duct, and that's it. And what we did before on that elbow shape here will be done on that elbow shape here, as we don't need that extension. So we will go to the modify tab and trim extend command, and then select that duct and that second one, and that's it. Here we have made it to be with an elbow shape that is most suitable for the design. Also, we can see that design or that full design in the 3D shape to make more sense for you. So we can select it, and then we press on that selection box. So as you see, this is our system. Here, this is the second variable air volume that is connected to that zone. Here, that zone consists of 3 air terminals, those 2 ones and that one. And here, that's the first variable air volume. Also, it's connected to those 2 air terminals. Very good. So that's about this step of our design. And on the next tutorial, we will continue the next tracks for our design. Hope that's clear right now. Thank you for watching and see you next tutorials.